Today we're going to be covering the derivatives of the 6 basic trig functions. So y equals sine x, y equals cosine x, y equals tan x, and then the reciprocals. Y equals cosecant x, y equals secant x, y equals cotan x. It is very helpful for you to be very familiar with your various trig functions and how they relate to each other. So for instance, you should know that cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. You should also know that these can be rewritten in terms of sine and cosine. You should also probably know various double angle formulas, sum and difference formulas. They're very helpful because occasionally you want to simplify the question before taking a derivative. Let's start with the derivatives of sine and cosine. So we are going to start with the limit definition. So if our function is sine x, and we want to derive the derivative of this, we're going to use, in fact, the derivative as a function of x is the limit as h approaches 0 of our function of x plus h minus our function at x all over h. Now, unlike the problems involving polynomials, this one's a little bit more complicated to unfold. We're going to end up using an angle addition formula. So if I apply this formula to this component, I end up with limit as h approaches 0, sine x cosine h plus cosine x sine h minus sine x all over h. I have a sine x here and here. I'm going to group those terms and factor out the sine x. And then I also have this term here. Remember that this limit as h approaches 0 of this is 0. The limit as h approaches 0 of sine h over h is 1. So I've shown that the derivative of sine x is cosine x. If you look at the graph of sine x, and you look at the slope of the tangent line at various points and then plot them, the slope here is about 1, or is exactly 1. Slope here is a little less than 1. Slope here is a little less than 1. Slope here is 0. And then if I continue, the slope gets negative and reaches a lowest point of -1 here. And then slope increases to 0 here. So if I trace this out, this generates the graph of cosine. So not only have we sort of demonstrated, have we proven it here, but just by looking at tangent lines and sort of estimating the slope at various points, you do end up confirming that graphically, that the slope of sine x does appear to follow cosine x. Now let's find the derivative of cosine x. So if we want to find the derivative of this, we again use the limit definition. We use a different angle addition formula for cosine. It works a little bit differently. It's cosine of the first one, cosine of the second one, minus the product of the sines of the first one and the sine of the second one. Same strategy. Both of these have a cosine x. We're going to group them and factor it out. this remaining term, we write this limit goes to 0, this limit goes to 1, and so we find that the derivative of cosine is negative sine x. Again, graphically, if we look at cosine x, and we estimate the slopes at various points, slope here is 0, slope gets negative and is negative 1 here, slope increases to 0 here, slope increases to 1 here, slope decreases to 0 here. So I've traced out a graph that looks like y equals negative sine x. So those are the derivatives of the first two trig functions. The derivatives of the remaining four can be derived most easily using these derivative rules. So again, if f of x equals sine x, derivative is cosine x. If f of x equals cosine x, derivative of this is negative sine x. We're going to use product and quotient rules to derive the remaining ones. Some of secant and cosecant can more easily be derived using chain rule, but some of you are learning the trig derivatives before you're learning chain rule, so I will go ahead and stick with just product and quotient. So if I have tangent x, I'm going to rewrite it as sine over cosine, and then apply quotient rule to find the derivative of this. So that's going to be derivative of the top times the bottom minus top times the derivative of the bottom over the bottom squared. This top becomes cosine squared plus sine squared. The bottom is just cosine squared. Remember, again, trig identities. We have a Pythagorean identity that says sine squared plus cosine squared is 1. We replace that with a 1, and then rewrite 1 over cosine squared as secant squared. So in other words, if your function is tangent x, the derivative is secant squared x. We can do something similar with cotangent x. Rewrite it as cosine x over sine x. Again, finding the derivative of this using quotient rule. So that's going to be derivative of the top times the bottom minus top times the derivative of the bottom over the bottom squared. Top is now negative sine squared minus cosine squared over sine squared. Factoring out the negative, that just becomes sine squared plus cosine squared. That again is 1. So we have a negative 1 over sine squared x. 1 over sine squared can be rewritten as cosecant squared. So, summary, if your function is cotan x, the derivative of that is negative cosecant squared x. Continuing along, what if our function is secant x? We can rewrite that as 1 over cosine x. Again, it's easier to derive this using chain rule. However, I'm going to use quotient rule here. So, derivative of the top is 0, because 1 is a constant, times the bottom, minus top times the derivative of the bottom, over the bottom squared. We end up with sine x over cosine squared x. That's frequently broken up as sine x over cosine x times 1 over cosine x, or we can put that in front. This will basically be a tangent, this will be a secant, so we write that as secant x tangent x. So again, our function is secant x, the derivative of this is secant x tan x. Finally, if our function is cosecant x, you write that as 1 over sine x, and then apply quotient rule. Derivative of 1 is still 0, times the bottom, minus top times the derivative of the bottom, over the bottom squared. This is now negative cosine x over sine squared x. I'm going to break that up as negative 1 over sine x times cosine x over sine x. That's going to turn into a negative cosecant x cotan x. So your function is negative cosecant x, cosecant x. The derivative of it is negative cosecant x cotan x. Now how are you going to memorize all these? I'm going to summarize the derivatives here. There are a couple of things that may help. First of all, derivatives of sine and cosine, they sort of switch, although you have to pay attention to the minus sign here. So that's a slightly separate block from the rest of these. However, there are a couple other patterns. Notice that the derivative of all the non-cofunctions are positive. The derivative of all the cofunctions are negative. Also, note that if you know the derivative of tangent is secant squared, you basically get the derivative of cotangent, because anything that no co. Once you make it a co, all of the derivative terms also become cos. That applies to secant and cosecant as well. Secant is secant tangent. Cosecant, because it's a co, it's negative, and it also converts secant to cosecant, tangent to cotangent. These little things will help you as you memorize these 6, because eventually these do need to be memorized very, very well. A little bit longer today. Hope that helps.